There are over 7 billion people in the world, and the big question is how to feed them. So how do states, countries increase that food supply, and what is the impact? We are already familiar with Thomas Malthus and the Malthusian theories. The idea from Chapter 2, population, that population increases exponentially, but food resources only grow arithmetically. In other words, the population is going to increase so much that eventually food will not be able to keep up with the amount of people that are trying to consume it. We'll have massive famine, and the earth will, which has already reached a maximum population, maximum capacity, will have devastation. However, on the flip side, there are other viewpoints. Julian Simon is a theorist who is considered a cornucopian, which is pretty much the opposite. The only thing limiting food supply is a lack of human inventiveness. The idea that, yes, we can feed 7 billion people around the world, and we can feed more than that. He says the greatest resource in the world is the human population. As we have more people, we have more smart people, more geniuses, and they are able to figure out how we can get more food. So what kind of options do farmers have and do states have? One is just expanding farmland. And historically, this is what people have done. You need more crops, you grow more. You don't have enough room on your space, you take farmland next to you and you continue to grow more. Core countries historically have relied on the colonies, their colonies, or now the periphery countries, to feed them. Where they ran out of space, they needed more farmland, pick up this other territory, it's now a colony, they can do the agricultural work, and as long as it's not something that's going to spoil, they can send it back to the mother country, so to speak. The impact is a loss of resources by cutting down trees, depletion of the soil, erosion, etc. Okay, it can be very harmful to the environment. And some of the high examples of that, one is a process called desertification, and second, salinization of soils. So what is desertification if you're not familiar? Essentially, it is the growth of deserts. Simple as that. It happens when you have overgrazing, maybe it's with cattle, and they are eating up all of the local vegetation, and as a result, you don't have the root systems there to hold on to this soil. This is very dangerous near deserts, and the vegetation gets destroyed, and then a laterite soil forms. Laterite is a very hard clay-like soil. It has lots of clay, it's got lots of iron in it, it becomes brick-like. And as a result, agriculture cannot grow. When you look at this map, the Sahel, this orange region, Sahel is the Arabic word for shore of the desert. This is where the Sahara Desert is growing, and it's moving further and further south, which has definitely negative impacts on the communities that live there. It is the fringe of the Sahara Desert. Every year, Nigeria, we're looking right here, loses about 0.6 kilometers of land to the expansion of the Sahara Desert. However, there is a way to fight back. I'm not going to click on the link, but you can go ahead and take a moment, pause the video, click on this link to see how they are fighting the desertification of the Sahel. Essentially, all countries across the Sahel of Africa have agreed to plant trees. They're creating a green wall across the continent, which is going to help hold on to that soil, make sure that rich topsoil does not blow away, does not get washed away with heavy rains, and that the people will be able to continue to have agriculture. Salinization is another devastation as a result of over-farming, and that is when salt gets into the soil so it's no longer arable. Now, that's generally not a problem in a place like Wisconsin because we don't have a lot of salt in the air, in the water, in the soil. However, in other parts of the world, some of the larger seas, which are salt, that is a problem. You have the Aral Sea, which is found in Central Asia. This is a satellite image of the sea in 1977. because under the Soviet era, Kazakhstan and Central Asian countries were part of the Sahara Desert, or sorry, they were a part of the Soviet Union. The two main tributaries into this river, the Amu Darya and the Sir Darya rivers, were used for irrigation. And so these are the main tributaries, the rivers that flow into the Aral Sea. But as they were diverted to allow for more irrigation, more farming in Central Asia, water would just be evaporating out of the sea. And without more inputs, then you saw the shoreline start to decrease. So this is how the sea looked in 1989, and by 2006 we're at this point. And now if you were to look at a satellite image, there are two separate seas, or two separate lakes. This is completely dried up here. The Aral Sea is now half of its original size. It was a saltwater sea, and so as the evaporation took place, there's now all of this salt left in the soil. And as heavy winds come, that salt blows into the nearby farmland, making too much salt in the soil, so it's considered salinized, and crops are not able to grow in high salt contented soil. Another problem is what they refer to as creative destruction. When the original landscape is altered by removing vegetation to raise other crops or livestock. This would be one of the large problems of the Great Depression and the Dust Bowl, as the native crops were taken away and replaced by wheat with that weaker root system we talked about last week. Was not able to hold onto the topsoil during the long periods of drought, and so the crops died, and then as heavy winds came, that rich topsoil would literally blow away. Another problem is the impact of urban sprawl. Not only does agriculture need to grow if we want to have more crops, but we have more people, and so cities are growing. In the United States, 200,000 hectares are lost every year, which is about 100,000 acres. This is often referred to as topicide. Yes, it's referring off of genocide. It's a destruction of something. In this case, destruction of topography. It is the complete destruction of a landscape to create a new landscape, which usually happens for development. If you think of the agricultural landscape that used to be around the area, completely getting destroyed to build a shopping mall or to build a subdivision. It's a complete new landscape that has been created. This has resulted in the loss of prime agricultural land. And then as agriculture grows and we have more land, and especially in the Great Plains, there's a high need for irrigation. In the Great Plains, it's technically a desert. And so they need to go ahead and pull up water from some place, and they're pulling it up from the aquifers below the ground. The problem is that 10% of all irrigated land is actually overwatered. Waterlog, having too much water into the soil, actually drowns out the plant's root systems, and so it's not the best system. Likewise, as you are throwing all this water into the air, and it's summertime in the Great Plains, there's a large percentage of it that doesn't even reach the root system. Water that we're pulling up out of the ground or throwing in the air is really just evaporating. And so it's depleting our water aquifers. Okay. The Ogallala Aquifer is a prime example of this. It is the largest underground water aquifer in the United States. It contains 30% of all the groundwater in the U.S. When you look at the map, it's pretty much throughout the Great Plains. It reaches from South Dakota, Wyoming, all the way south down into Texas. Okay, so it includes 8 different states. This is the main water source for people living in these states. It is also the main source for irrigation for crops in this space. And it's estimated that about 69% of all of this water is going to be used up by the year 2060, which may not sound like that big of an issue. There's still 31% left, but in order to replace all that water, it's going to take between 500 to 1,300 years of precipitation, of rainfall to trickle back down in order to refill this aquifer that we've been depleting. So another option, you don't want to expand agriculture, is to increase fishing in order to relieve the pressure on land. If we just started consuming more fish, which is something we've done, fish extraction has nearly quadrupled in the past 50, now nearly 60 years. In 1960, the average person consumed about 17 kilocalories per day of fish. By 2010, that changed from 17 to 30 kilocalories. But if consumption's only doubled, why is extraction quadrupled? And primarily because not all of what's being extracted out of the sea is for humans. 2/3 of ocean fish extraction is for human food. A lot of other fish extraction is being used for feed for poultry, for hogs. Think of pet food, animal food, and then the industries with fish oil, vitamins, and that kind of thing. Here's a map depicting how much change has taken place. Here's a map of fish extraction in 1950. The red is going to be the areas of highest extraction, and then the orange, and then the blue. Make the same comparison to 2006 in the amount of extraction and over-extraction that's taking place in the world. Essentially, this is not sustainable to keep up. And so as a result, we have the creation of aquaculture, which includes cultivation of seafood under controlled conditions. This could be aquaculture in the sense of clams, in the sense of seaweed really, but also in fish. Here's an example of salmon farming, where you can go ahead and aquaculture places have salmon being farmed in these areas as young minnows, and then as they get larger, getting moved into larger tanks, and then never being in the open ocean, so that people can continue to get their salmon and fish that they want. However, there is starting to see a connection between these fish getting higher saturated fat, just like in the farming industry with cattle. Beef cows that have been kept in feedlots are not as healthy as free-range or open-range cattle. Likewise, fish that are raised in farming situations like this are not as healthy as fish that are caught in the wild. But the oceans are huge. So what? Tuna, which is one of these animals that we do eat quite a bit, is a huge predatory fish, and the population has decreased by about 90% in those past 50 years. And so what is that ecological impact going to be on the food system? Other extractive industries include mining, natural resources such as copper, oil, natural gas, etc. Anything that's being taken out of the earth. Remember those primary economic activities. Even though we've been focusing on agriculture, extractive industries, rural land use is connected to these industries as well. At this moment, I'm going to pause just to make sure that we can get through the entire PowerPoint. You'll want to go ahead and click on the next video for part 2 of this PowerPoint.